All right, so you guys don't get to see my red face right now, but I thought I recorded the whole writing of this program, and the people in the room listened to me the whole time, talking to myself and nobody else because the computer was not recording. So, really quickly, let me run through what you missed. We decided that when trying to write the dropStones method with two separate arrays, it was really difficult. So, it was better to go back and make what's called a two-dimensional array. The two-dimensional array, you can think of like a chessboard or a battleship game, just anytime you have a grid. And I think I have an example down here where we initialize it. We say I have two sides of the board, each with 7 pits, and then I just use these two indices to say which part of the grid. So think battleship. I want to go to A7, or I want to go to B9. So I want to go to the board at side S and pit P. And we pre-fill all these to be 4s. We have a display method that we wrote that displays the board. Will display the computer side of the board backward. That's why this board loop is counting down. Displays the player side of the board forward. That's why this one's counting up. And it did display the board nicely. So let me just comment out some of the stuff that we were using for testing our dropStones method. And there you see our nice boards printed out. So that's actually the same as the other Java program that we wrote and made a video of. But what is now different is this dropStones method. We said, to write this method, tell me which side I'm starting on, tell me which pit I'm starting on, and now I can actually use math in order to do all my navigating and wrapping around. And you're not going to hear the logic of thinking through this because we didn't write this top to bottom. We wrote it, kind of sporadically, and then went back and made additions when we needed to. But the first thing we did is said, I want to keep track of whether or not I should drop into the store. And the first time that you hit a store, it's definitely going to be yours or the player that's currently taking their turn. And then you're going to constantly alternate. So if I'm the human player, the first store I come across is the human player store. The next time it's going to be the computer store. And the time after that, it's going to be back to my store. So it's just going to keep track of that for me to decide if we want to actually drop in the store or not. Next thing we did is we said, I want to keep track of my stones I have, take them out of the board at that side and pit. And then I also want to make sure that pit's empty, so set it back to 0. While there are stones left, we are going to go to the next pit because we started at the pit I took them out of, so I want to go to the next pit. And we want to first check to see if that pit index is a store. So that means it's the length of the side minus 1. So the length is 7. If the index is 6, it means I'm in a store. And if it's not my store, just skip it. Just add one more to my pit index and ignore it entirely. Otherwise, or either case, the next store I see is going to be the opposite. So I'm going to keep swapping between. This is just swapping that Boolean. Now that we've gotten my pit index to the proper place, the next thing we'll do is check to see if we've gone off the edge of the board. So is the pit index greater than or equal to the length of the board? And we say greater than or equal to, not just equal, because you don't want an array index out of bounds. So if there's a way to double index, like we have right here, and we're doing double indexing, you want to make sure that you're always checking that your bound condition for your array is protected. If we are too far, then we go back to the first pit again, and we go back to the other side. And this is just a little bit of math that gets us to the correct side index. So if we have a 0 for my side index and I add 1, I have the value 1. 1 divided by 2 is 0 with a 1 remainder. So 0 leads to a 1. If I have a 1 for my side index, 1 plus 1 is 2. 2 divided by 2 goes in evenly with 0 remainder. So 1 ends up leading to a 0. At this point, I know I'm at the appropriate side and pit. So I add a stone there and take one out of my hand. And we did a couple tests down here just to make sure that it behaves the way that we would expect. Actually, I'll leave that commented out first. So let's start with a very simple one. We have the computer dropping stones starting at its 0th pit. So that's this pit on the computer side. It became a 0 and we dropped 4 stones. That looks good. And we said, well, what happens if I drop at the last pit and we do wraparounding? So that's this pit turned into a 0, added 1 to the computer store, and then 1, 2, 3. So there's my 4 stones. They dropped appropriately. And then we said, let's actually forced my board to have 12 stones at a position. So it said, let's add 12 stones and see if it'll wrap around appropriately twice. So we put 12 stones in the player's last pit. It added one to the player pit, one to all of the computer side, skipped the computer pit, and then added one to this side. And then that was also true if we did this on the computer side. 0, 0. Test it one more time. There's my 12. 1, 2, 3, 4, 5, 6. Skip 7, 8, 9, 10, 11. Oh, I miscounted. 1, 2, 3, 4, 5, 6, 7. Skip 8, 9, 10, 11, 12. Booyah, it works. This is the B version. We haven't yet gotten to the point of checking to see if I steal stones. I think that is a special method. It's probably going to be something like when we're done, so when there's no stones left, call a method check for steal, right? And then that could be its own method that does that. So that's it for now. And you got the abridged version of this because I'm not going to say as much as I did last time. Bye now.